Okay, now let's solve a second order differential equation with the non-constant coefficients, variable coefficients. So the equation is 1 minus x square y double prime minus 2 xy prime and plus 2y is equal to 0. Okay, so let's try to write its power series. So we start from y. So for y we know that maybe I put some more, and then from y I will write the power series of y prime and then power series of y double prime. So yeah, so y is with 2, so 2 in the sigma notation. In the sigma notation, sigma m is equal to 0 to infinity am x power m. That was equal to 0. Now I go backward, so plus 2y, and then for y prime it will be m x power m minus 1, so it will be x power m minus 1 am m, and then it's sigma notation, but in this case I will lose one term, so m will be start from 1 to infinity. Okay, and then it was minus 2x over here, and then for y double prime it will be again for this it will be x power m minus 2, okay, a m, and then it will be m into m minus 1. Okay, these are the coefficients, so we are actually essentially going backwards. So m is equal to 2, so because I will lose two terms with respect to y, so it will be m is equal to 2 to infinity, and then it will be 1 minus x square. So just sticking to the sigma notation, then I can write it like this. So 1 multiplied by this, so it will be same. M is equal to 2 infinity m into m minus 1 am x power m minus 2, and now x square multiplied by this, so I will take minus over here and then multiply it with x square. So m is equal to 2 to infinity m minus 1 and am, and x was square and x minus 2, so it will be x power m. Okay, now minus I take 2x inside, so 2m m is equal to 1 infinity am, and then it will be x power m, because x and then power 1 and x power m minus 1 is x power 1 m, and then I take 2 inside, or rather actually we don't need to bring 2 inside, but even without that it should be fine. But anyway, 2 am x power m is equal to 0. So now I have to make all these sigma notations compatible with each other. So I will choose x power m, so I need to adjust this x power m. So if I want to adjust this x power m, so I will bring each two terms forward. Okay, I will add 2, so it will be x power m, and then there will be term x m plus am plus 2, and then m minus 1 will become m plus 1, and m will become m plus 2. Oops, I don't have any space left over here, then let me write it again. Maybe I start from here, x power m, a power am plus 1, m plus 1, and then m plus 2, and then it will be sigma. So now it will be okay. So now since I have increased two terms over here, so I have to decrease the index value by 2. So m is equal to 2 will become 0 and infinity will remain infinity. Okay, and then from here, so it is already x power m, so I don't need to change this term. So I just need to change the index value over here. So for example, if I take the m is equal to 0, then that term will be 0. Okay, because m is equal to 0, then that will make it 0. If I take m is equal to 1, then due to m minus 1, it will be also 0. So this means that I don't need to make any change into here. I just simply can write m is equal to 0, because the first two terms will be 0 in this case. And then it will be m into m minus 1. I can write it like this without changing anything. Okay. Similarly for here, it is x power m is already here. So if I want to start from m is equal to 0, so because m is equal to 0, this term will become 0. So I can just simply write m is equal to 0 to infinity to m am x power m. And now this term is already with 2am. So m is equal to 0 to infinity to am x power m is equal to 0. So now every term has x power m as the leading variable, and all sigmas are starting from 0 to infinity. So then I can combine them. Okay, so what I can write is m plus 2, m plus 1, am plus 2, okay, and then minus m into m minus 1, am minus 2, am, and then plus 2 am, and then whole times x power m is equal to 0. So, and then I can even put sigma over here with this 0 to infinity. So sigma m is equal to 0 to infinity. So now this whole term in the parenthesis should be 0 in order for this equation to hold true. So we can simplify it. Well, how can we simplify it? M plus 2, m plus 1, am plus 2, and then I can combine these am terms. So what it will be? So it will be m square minus m, and then it will be plus 2m, then minus 2, am is equal to 0. So m plus 2, m plus 1, am plus 2, am plus 2, and then I can see that I can factorize it. Okay. I take m as common, so it will be m minus 1, and then I 2 as common, it will be m minus 1. Am is equal to 0. So m plus 2, m plus 1, am plus 2 minus, so now it will be m plus 2, m minus 1, am. So now you can see that m plus 2 is common, so it can be cancelled out from this equation. So now what we get is am plus 2 is equal to m minus 1 over m plus 1 am. So this is the simple recursive equation we get. So now we can generate the coefficients. So m, if we start from m is equal to 0, so the yeah, in this case we can start from m is equal to 0, because that we will get a naught, and then we will start from a2 actually. So 0, then 1, and then 2, then 3, then 4. We can add even more terms. 5, 6. Okay, that should be enough, I think. So with this, then we will get what are the terms which we will get. With 0 I will get a2. So first term that I will get will be a2. Then I will get in sequence a3, a4, a5, a6, and a7 coefficients. So equal, 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 equal. Okay. So on the other hand, what I will get m minus 1 over m plus 1. So if m is 0, then I will get minus 1. Okay. If m is 1, then I will get 0, and then 1 in a sequence 2, and then 3, and then 4, and then 8, and then I will get 5. So over, 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 over. So what I will get, m plus 1. M plus 1 is 0 plus 1 is 1. So 1. Then I will get 2, 3, 4, 5, 6, 7. Okay. And then what I will get over here is, because with 0, so I will get a0, a1, a2, a3, a4, and a5, a6. Okay. And then now it's the time to simplify it. So it is minus a naught, that is 0, and now this will be 1 by 1/3 of a2. So 1/3 of a2 is minus 1/3 of a naught. 2/4 of a3, 2/4 of a3 is, that will be 0. So every alternate terms is expected to be 0 in this case. And then 3/5 of a4, 3/5 of a4 means this one. Okay, so 3 cancels with 3, so it will be and then because it was minus and then minus, and then it will be also minus over here. Okay, so now because 3/5 multiplied by 1/3, so 3 will cancel with 3, and then it will be minus a naught over 5, and then this will be depend on a5. a5 was 0, so it is 0, and then again it will be 5 will cancel with 5, so it will be minus a naught over 7. So therefore the solution in terms of the power series will be a naught plus a1x plus a2x square plus a3 x cube plus a4 x4 plus a5 x5 plus a6 x6 plus a7 x7, and so on. So in this case we are starting from a2 and a3, so therefore a0 and a1 will be the arbitrary constants. So a naught plus a1x will be there, and now a2 is represented in terms of a naught, so minus a naught x square, and this is 0, and then a4 is minus a naught by 3 x4 and then this is 0, then the next term is minus a naught by 5 x6, and then so on. So therefore we get